Let's look a bit more about the statistic known as correlation. How can this help us in the business of teaching and learning? I'm going to use specific examples from the research literature. 150 11-year-old mathematics students. They sat two tests. One was a standard test of the capacity of working memory. This is the size of a part of the brain, and the test is standard. And the other one was a normal test of mathematics, the kind of skills they have gained in the curriculum they were following. The results are put on a sheet, a spreadsheet, something like this, where the maths marks are put down in a column for each student, and their working memory capacity, which comes a number also, was put down in the second column. The question is, do these things relate? Are they connected in some way? Because the data is normally distributed, integer data, Pearson correlation is the method to use. And the result was a value of 0.69, published in the European Journal of Educational Research. Now the question is, what does that mean? Let's remember that there are three methods of correlation. In this study, correctly, they used the Pearson method because it fitted the data. The other two methods, named after famous statisticians of 100 years ago, have an appropriate place with different kinds of data. If the value had been -1, it would mean that those who were highest in one test were lowest in the other. If the value had been 0, there'd been no pattern in the results at all. If the result had been +1, it would mean that the order of scores was exactly the same in the two tests. Those who were highest in the first were highest in the second, and so on, down to the order of merit. Now the researcher here got 0.69. Now that's a very high value. It means there's a very strong tendency for those with high working memory to perform best in mathematics. Now there's a warning. It doesn't imply that one causes the other. It doesn't imply that high working memory capacity caused the performance, or that mathematics ability caused the high working memory. It's just that they are related in some way. But in fact, other research that had been done previously shows that the capacity of working memory controls much examination performance. Correlation doesn't tell us that, but other research has shown us that. So the researcher can correctly deduce that working memory capacity was controlling mathematics performance in this country at this level. Statistics has helped us here. Here's another study, much bigger sample, older students aged 17, 3 sciences and mathematics. All the marks were correlated against each other. In other words, are those who are good at biology also good at chemistry? And that's the figures they got. These are very, very high. What does it mean? It means that those who did well in any one of these subjects also tended to do very well in the others. And those who did poorly in any one of these subjects also tended to do poorly in all the other 3. It doesn't say it's cause and effect, but it does say they're connected. The results were published in that international journal. Further statistical analysis showed that, in fact, in all 4 subjects in this country, they were rewarding the same skill, just recall, memory. Therefore, it's not surprising the results followed a similar pattern. Now that raises all sorts of questions about curricula, teaching, presentation, and indeed even more so about the national examinations that are being used in this particular country.